Okay, so in this video we're going to have a look quickly at what kilowatt hours are and how we calculate the cost of energy. So to start with, we're going to have a look back at our equation for power that we looked at just before, which is power equals energy divided by time. We're going to have a think of this situation here. How much energy does a 2 kilowatt kettle use in 3 hours? Now remember before we said that to find out what the equation is, to rearrange it from a triangle, we cover it what we want to know. Now we want to know what energy is. So energy equals power times time. And I said before that the power has to be in watts and that the time has to be in seconds to give us an answer of energy in joules. Okay, now that involves a lot of conversion here. Okay, we've got 2 kilowatt hours for the power and 3 hours for the time. Now we learnt quickly that 1 kilowatt is equal to 1000 watts. Therefore 2 kilowatts is going to be 2 times that 2000. So the power here is 2 times 1000 or 2000 watts times the time. Now we've got 3 hours and it has to be in seconds. So to do that, we do 3 times hours, because that's how many hours we are. Then there's 60 minutes in an hour and there's 60 seconds in a minute. Okay, so we get this sum 3 times 60 times 60. Now I'm going to quickly do it on the calculator because I've forgotten to work it out before the video started. So we get 3 times 60 times 60, and that is equal to 10,800 minutes. We've got 2,000 times 10,800. So if we do that sum, we get the answer 21,600,000 joules. Okay, now that's not a huge amount of energy. Like, it looks massive there, but if you think about how much time you might use the kettle each week, that's probably how much you'll use the kettle for each week. And energy companies think that that's a little bit scary, and they think that you don't want to see bills that have got millions and millions of joules of energy on. Therefore they use a different unit. They use something called the kilowatt hour. It's written like that. Now it's a unit of energy, but for the kilowatt hour what we have to do is we have to use power in kilowatts and we use time in hours, hence the time kilowatt hour. So instead I'm going to do this in a different colour. I'm going to write this as kilowatt hours, and that's equal to the power in kilowatts and the time in hours. We're going to see a bit of a difference. Okay, so my power in kilowatts is just 2, my time in hours is just 3, and that gives me a nice simple answer of 6 kilowatt hours, which you'll probably see is slightly less scary than this answer here. So, or that's what energy companies think. Okay, so the kilowatt hour is something that energy companies use to make your bills less scary, and they make the numbers more manageable and easier to understand. So let's have a look at that in just another kind of recap it. So energy is power times time. If you want to know the energy in joules, your power must be in watts and your time must be in seconds. So to calculate energy in joules, you have to use watts and seconds. To calculate energy in kilowatt hours, as in it's another unit of energy, it's just a number of joules, we have to use our power in kilowatts and our time in hours. It's quite easy to remember because of the name of kilowatt hours. So 1 kilowatt hour is defined as the energy that a 1 kilowatt device uses in 1 hour. So if you had an oven that was 1 kilowatt of power and you put it on for an hour, it would by definition use 1 kilowatt hour of energy. It's a unit of energy. That's a really important thing to remember. It's not a unit of power, it's a unit of energy. Okay, now if we think about that, that means it's 1000 watts times how many seconds are in an hour in joules, so 60 times 60. And that gives me, 60 times 60 gives me 3600 plus an extra 3 zeros there. So that gives me, it's 3,600,000 joules. So all 1 kilowatt an hour is a set of 3,600,000 joules. Okay, so let's think about how we then use this. If a kettle, which we worked out, uses 6 kilowatt hours of energy, how much would this cost? Now this is how your electricity companies then use this kilowatt hour unit to work out the price of things. So the cost of electricity is approximately 15 pence per kilowatt hour. That's slightly over what it is. It's more about 13.6, something like that pence, but it's an easy number to use. So if we think about it's got 6 kilowatt hours of energy, if each kilowatt hour is 15 pence, then 6 kilowatt hours is going to cost 6 times 15 pence, which all is just equal to 90p. So it costs about 90p to use that kettle for 6 kilowatt hours, to use that 2 kilowatt kettle for 3 hours. Now all we've done there is a simple equation that you might not think of as an actual equation, but we've just done 6 times 15, where 6 is the number of kilowatt hours used and 15p is just the cost per kilowatt hour. the cost of electricity per kilowatt hour. And this is exactly what your electricity provider does to work out how much your bill is. Now, obviously, you're going to use a little bit more than 6 kilowatt hours, and the price might not be just 15 pence, and sometimes they have base rates, etc. So it's a little bit harder than that. But generally, this is how it works. Now, we can have look at a bit more difficult of a problem. We've got here, how many minutes can a 1.5 kilowatt oven be used for on £1 worth of electricity? Okay, now £1 worth of electricity is 100 pence. And we know that electricity generally costs about 15 pence per kilowatt hour. So 100 pence is going to pay for 6.67 kilowatt hours worth of electricity. Okay, because we've got 100 divided by 15, divided by the price of 1, it gives 6.67. Okay. Now, an oven that is 1 kilowatt or 1 kilowatt will use each hour 1 kilowatt hour, 1.5 kilowatt hours, sorry, even. Okay. So every hour, this oven's going to use 1.5 kilowatt hours of energy. We've got 6.67 kilowatt hours worth to go. So to see how long we can do that for, we do 6.67 divided by 1.5, and that gives us an answer of 4.4 reoccurring. Okay, so this is how many hours you can use your kilowatt hour, your 1.5 kilowatt oven for on £1 worth of electricity. Now, if you leave that as an answer, it's not too bad, but they usually like it to be in minutes instead, or hours and minutes. So we know this is 4 hours plus 44 basically over 100 nus of an hour. Okay, it's not 4 hours and 40 minutes, as a lot of people are right. This is 0.4 of an hour. Okay, now 0.4 of an hour, or 0.444 of an hour, all we need to do is this number, 0.44444, etc., times 60. That's how many minutes you get. Okay, now 0.444 worth of 60 minutes is actually equal to 26.6. You can't really see that. So this kettle can be used for 4 hours and 26.6 minutes. Not kettle, oven. Okay. So once you've used this oven for 4 hours and 26.6 minutes, you'll have used £1 worth of electricity. So that's an example of a question that you could be given. That's probably a little bit harder than you usually get given. But that's just using the idea of kilowatt hours and price. Now, often also this links in with the problems that we looked at before in terms of power, energy and time, or power, current and voltage, and they put them all together in longer questions. But this is one example of a question that could be used. So it's really important generally just to remember that the kilowatt hour is simply a unit used by electricity companies because it's easier, in inverted commas, it's easier for people to read, although it's actually harder to calculate, harder to think about, and it's smaller, so less scary. And all it is the same equation as normal, energy equals power times time, but instead of using watts and seconds to give us energy in joules, it uses kilowatts and hours to give us energy in kilowatt hours, 1 kilowatt hour being the energy a 1 kilowatt device uses in 1 hour, and equal to 3,600,000 joules.